everyone. So it's the first time I'm doing a conference like this through the web. So I hope I'll do fine. I'm going to share my slides and we can start the talk. All right, so share screen. All right. So I hope everyone sees the slides well. I'm going to put them like this. So they are in my browser, so I hopefully it's big enough for everyone to see. So I'm Tarek. I work at Mozilla. I've been working at Mozilla for the past 8 years or something like that. I work remotely from France, and I've been working on both the server side and the client side of Firefox. And I'm here to talk about a tool I've written for Mozilla to test web services, which is called Molotov. So Molotov is a Python-free load testing framework that we use to test web services at Mozilla whenever we need to make sure that a web service we want to deploy is going to be fast enough for what it needs to do. I guess everyone here knows what's Firefox, so it's the browser you should use. And Firefox is a desktop application. It also comes as an application for Android, and it's a web browser that has many other things around. So Mozilla, the company and the organization behind Firefox, is doing a lot of other stuff than Firefox, the browser. So we have a big web application. For example, the two major web apps we have are the Mozilla Developer Network, MDN, which is a place you've probably been to whenever you look for something about HTML or CSS. It's a huge documentation center. We've translated in many languages. I'm pretty sure we have Portuguese and Brazilian that you can use to do whatever you want with JavaScript or HTML or CSS. And we have a full team dedicated on Mozilla that works to make it as great as possible. We have Firefox add-ons, which is basically where you can upload an add-on if you're an add-on developer to make it available for people. And you can also upload themes and web extensions. It's a pretty big website as well. Both are written in Django. So that's for the web apps. And then we have many web services. So if you use Firefox and you're synchronizing your bookmark, there is a Python web service called Firefox Sync, which is basically going to synchronize your bookmark. So when you add a bookmark on your desktop, Firefox is going to appear on your phone and vice versa. There are also other services like screenshots, SAMD, and many other. I think we have like maybe 20 web services around Firefox when you use it. So there are a lot of app in the cloud to make the Firefox experience cool. So from a testing point of view, if I look at web apps and if I try to define what's a web app, it's basically an application that queries a bunch of backends like databases or Redis backend or whatever that contains some data. Grab that data given a query and then spits out some HTML. That's like the most basic definition I could find about what's a web app. And in comparison, a web service is basically the same stuff, but instead of spitting out HTML, it's gonna spit out JSON most of the time. That can be reused by a heavy client like Firefox or by another application that queries the web service. And I guess the main difference between a web app and a web service is that the web app usually follows no particular pattern for its URLs. You can just, as a human, you click around and see stuff. Whereas a web service is usually following a pattern like a REST API, for example, where you will find data in a very specific URLs, and you will use specific HTTP verbs to query the web service. But that's basically the difference. And if I go into more details, web application, going to set up some JavaScript on your browser to execute it. It's going to do some cookies and open some WebSockets. As a user, you also have a way to authenticate to the application. And most of the time for big apps, you will have some caching happening both from the client side and on the server side. I'm telling you about those things because that's basically the biggest difference when you're going to do some load testing between a web app and a web service. On the other side, a web service is something we try to keep as dumb as possible. It's a thin layer on the top of one or several other service, like a database or any service that provides some data. And it's going to provide the data as flat as possible to be reused by something that's smarter. For example, Firefox Sync, when you open Firefox and you add a bookmark or you try to synchronize your bookmark, the only stuff that the web service is doing is a big SQL query on the database. Hey, please give me the encrypted bookmark for that user and sending it back to you. And everything that's smart is happening on the client side. Like decrypting the data and sorting it and that kind of stuff. And web services are also services that can be used between apps. So it's not always a client that calls it. It can be another application. So it does some app-to-app transactions. Like for example, if you have, we have a web payment service that's going to be used by application that needs to do some online payment. And usually everything that's happened between two web services is stateless. So there is this REST API you call to do something, it does it, and end of the story. We don't keep any session between services. So why do we test web services? So the main reason we're doing some testing, and I'm pretty sure everyone here have the same reason, not only for load testing, is that when you do some testing, that's when you really understand how the application behaves, because there is always a gap between what the developer thinks the application does and what it really does in real life. And adding some tests, even if it's load tests, is a good way to find out that it's really the case. And it's also a good way to make sure that when you write a scenario to test your web service, it makes sense, and that the way you implement your scenario if it doesn't make any sense, maybe there is a design problem in your web service. And of course, when you do some load testing, the goal is to find the bottlenecks of your application, not to fix them, but to find them and to tell the developer, okay, we did some load testing on your web service. When we do that kind of load, everything crashes. Is this okay or not? Do you need to fix it, or is for the job, is it good enough? Stuff like that. And last but not least, when you do some load testing on a web service, it will give you a hint of how you're going to deploy it, because if the load test shows a web service uses a lot of RAM, maybe you're going to deploy servers that have a lot of RAM but not a lot of CPU, or vice versa. So that's called sizing, and that's a very important step when you do some deployment. So when you put an application, a web service or a web app under stress, you want to see what's going to be exhausted first. So like I said before, it can be the RAM, the memory. For example, if you have a web service that is keeping a lot of stuff in memory and is not careful about how it grows, maybe in a couple of minutes, you're going to exhaust all the RAM on the machine and it's going to be down. So we want to check that this is not happening, and if it's happening, we want to understand how much load it takes to reach that point. Maybe it's not going to be the RAM. For example, if you have a service that's doing a lot of encryption work, maybe you're going to exhaust the CPU, is going to be 100%, and then everything is going to slow down and not respond anymore. So you want to know when you reach that point. Or maybe it's going to be the sockets you're opening to do some queries on other service. For example, if you have a web service which only calls a database through a TCP socket, maybe you're going to exhaust all the FDs you have on your system, and when you reach that point, it's going to be erratic. So the goal here is to find out how the app under stress behave and to understand it. And also, when you reach that point, you want to make sure that the application goes back to normal once it's not under stress anymore. Because for many web services, usually what happens is that we're going to put a lot of load on the service, it's going to break, and then everything is going to be broken even though the load is down to a normal level again. Why? It's because the developer won't do a good job at making sure that, for example, a pool of sockets is doing a good job at cleaning everything once the pool is full and this kind of stuff. So that's important stuff to look at. If you're a Python developer and you're doing some web services, you have a plethora of framework out there that you can use to develop your web service. You can use Django, Flask, you can use AIO, HTTP, or whatever framework you want to use. But one common issue we find is when you use a synchronous framework like Django or Flask, the way it works, when a request comes in, it's going to block the process, and it's going to wait for to finish it to take the next one. So maybe it's fine, maybe it's okay for what you need to do, but in case you need to be able to respond to a lot of concurrent requests, you might have a problem of a lack of parallelism with those frameworks. So maybe it will be time to move to another framework. And a load test is a good way to find out. And like I said before, most web services are just thin layer that are sitting there and doing some IO bound work, calling a SQL server, waiting for the answer and sending back the results after a little bit of serialization. And on those, when you do some load testing, you usually find issues in the pool of connectors you're using for whatever service you use in the web service. And you start to have issues like too many open files, too many connections, or for MySQL, a common one is the MySQL server has gone away error, which happens when your web service stays around for hours and doesn't have a pool of connector that recycles connectors. So a load test usually catch that. Connection timeouts and stuff like that. And for the memory, if you're deploying your web services on Linux, you will often have issues like the server restarts or your service is going to be killed by the system with the infamous OM killer, just because load testing pushed a service, whether it's your web service or a cache like Redis or Memcache, to eat all the RAM. So that's the three most common problems we find when we do some load testing. So a healthy web service is a web service where you know its limitation. You know that when it reaches this amount of concurrent requests, something is going to break, whether it's the CPU or the memory. And it has a proper behavior when it happens, which means it tells the next client, yeah, okay, I can't answer anymore to your requests. Here is a 503. Please come back later. And when the user come back later, everything is working again. And the third point is it has a design that allows scaling if you need it. So for it can be fine that your web service is able to have a load of, I don't know, 10 user, concurrent user. Maybe that's good enough for what you're deploying. But if in the future you need to have 20, 100 user, how are you going to scale that? Are you able to deploy the same web service on 10 different boxes? Is this going to work with the architecture of your web service, or will you have some limitation there? So the bottom line is that when you do some load test, usually there is zero chance nothing is going to break badly and needs to be fixed. I mean, in the past few years using Molotov, I've never seen a web service that didn't have an issue somewhere we needed to fix, unless the developer did some load testing on its side. But usually we have a pool of connectors somewhere to fix, or we have we used, I don't know, Flask, and it was not good enough for the job, so we had to move to another framework. It's very common to find issues, and it's important to do it. So when you do some load testing on web service, it's done in 3 steps. You want to send some realistic load to the web service using a real user scenario. You don't want to like just bang the service with random query. That's not load testing, that's fuzz testing. So when you do some load testing, you need to have a user scenario you understand, and you want to send that to the web service to see how it behaves. Once this is done, you want to collect some metrics of what's going on, metrics that have to be collected on the server side, and you do that again and again until everything works as expected. To do that, you have 2 ways to do it. You can use a single box, like I don't know, a laptop or a server, or you can do it distributed. In many cases, a single box is good enough because most web services are IO bound, and you're going to kill it very fast by sending a lot of queries, concurrent queries. And sometimes, in some cases, you want to specifically do some distributed load test because you want to make sure that you try to load test it when it's deployed, for example, on Amazon on several zones in the world, or you want to make sure that you have the proper load balancing when the queries are coming from several IPs. But most of the time, just trying to do some testing from a single endpoint is good enough. In terms of metrics you're getting when you do some load testing, it's important to do the metrics on the web service server and not on the server side, on the client side, because the network contention and the fact that the network can change from one run to the other give you accurate results. And a lot of people are thinking that the results they get from tools like Apache Bench, AB, like it gives you a number of requests per second is accurate, but it's not. And you have to make sure that you're going to grab these numbers on the server side. And for example, if you have like a good box and a good connection, you can have like way better results on a service than if you would use a bad machine on a bad network. It makes a lot of difference. So make sure you grab the metrics on the server side. So there are a lot of existing tools out there. You have Apache Bench. You have Boom, a tool I've written, which is similar to Apache Bench. There is another tool called JMeter, which is written in Java. I tried to use it a few years ago, but it's a bit of a mess because you have to use your mouse to write actual tests, and it's like it's a big mess to do like a proper testing with it. There is another one called Grinder, which is pretty cool. It's written in Python. The only so you can write your test in actual Python. The only problem is that every time you want to run a test, you have to use at least 1 GB of RAM on the box that's doing the test, because it's going to use the Java virtual machine and load Python, and that's a lot of things to load in memory just to run a single test. There are other tools. There is one called Bees with Machine Gun. It's basically a script that uses Amazon to deploy nodes to do some testing. The name is cool, Bees with Machine Guns. And it's deploying a lot of nodes on Amazon and then do some load testing. The only issue is that I think it's using SSH to do that. So if a machine is lost, you don't have any way to get back to it. And it's good if you want to do a little test for a few minutes, but if you want to do a long run test, it's not going to work well. And there is Locust, which is based on gevent and ZeroMQ, which is pretty cool. So at Mozilla, back in 2015, we started to write our own test tool because all the tests that were existing were not fitting our needs. And the tool we started to write was quite similar to Locust. It was based on gevent. It used the unit test model, so you could write load tests using like unit test classes. It uses a ZeroMQ broker as well, but I guess the only difference is that instead of having a central piece that would be deployed to run the test on several boxes, we wanted to have the central piece deployed by Amazon using the orchestrator they have there. And we wanted to use the metrics provided by a tool called Datadog, a service called Datadog. So it was very Mozilla specific, and that's why we didn't use tools like Locust. It worked well, but the only issue we had was about making sure that when we ran the test for hours, we didn't lose a node in the process. And it was very hard to do something that worked well. And we ended up thinking that it was a better idea to write a single tool to do some load testing from a single box, and then let Amazon do all the built-in, all the orchestration, because they have all the tools you need to do that, especially now. So a simple tool to write load tests quickly, so that's Molotov, and then we embed those load tests in Docker image and then let Amazon do the work for us. So basically it's going to run a bunch of boxes using Docker, run the test, shut down everything, and then we can look at the metrics and see what's going on with whatever service. But again, doing a distributed test is only when we do like a very heavy load testing campaign, and we don't do that often. Most of the time, a single box is good enough to break a web service anyway. Molotov. So I'm done with all the reason why we wrote Molotov, and now going forward in this presentation, I'll talk about Molotov, the tool. So Molotov, like I said, is a tool you can use to write load tests on a single node. It's not distributed. It doesn't have any client server interaction. It's just a Python script that is going to hammer a single endpoint for you. It's a very, very simple framework. I wanted to create something that's let people write almost pure Python function that they can use to stress a service. It's very extensible, and it has a lot of, it can let you do a lot of concurrency because it's based on coroutine. You can run several processes. So for example, when you write a Molotov test, you can send, I don't know, like 1,000 concurrent requests on a single endpoint, and then you can run several processes. So at the end of the day, from a single box, you can create a lot of load. It's based on AIO HTTP, which is a framework based on async IO. And it's very, very simple to write load tests using Molotov. So like I said earlier, a single laptop is good enough usually to break anything. For instance, we had a service, we had to load test on Mozilla, and in 5 minutes, we were able to just bend it to its knee with just one laptop connected to the network. Because using asynchronous frameworks, you can like create a lot of concurrent requests. So we were able to generate over 30,000 requests on the endpoint and just killed it. So if you're trying to load test a web service that needs to provide less than a few dozen of 1,000 requests per second, usually a single endpoint is good enough. So this is a very simple example on how you can write a Molotov test. So you have to import the Molotov module, and then we have a coroutine called Scenarii that you can use against a decorator called Scenarii you can use against a coroutine. And when you do that, you can use a session variable that's provided by the framework to do some testing against an endpoint. In this example, I'm just calling the HTTP some API endpoint and checking that the result is going to be, the status of the response is going to be 200. And in the command line, I can call Molotov, this file, example.py. I'm going to run 10 processes and 200 workers. It's the W option. So basically here, by doing this call, I'm doing a load of 2,000 concurrent queries against this endpoint and making sure that I don't have any error coming out of the server. So that's the basic example. You can do several scenarios. Here I have two different scenarios, do this and do that. So the first one calls /1 and the second one /2. The second one grabs the JSON result from the server and makes sure that there is a result key and that the result key value is okay. When Molotov sees this kind of test, every time a coroutine is going to start a test, it's going to pick randomly one of the scenarios. So here, it's going to pick either do this or do that. So when you run this thing for quite some time, you will have 50% of the calls is going to be the do this and 50% do that. You can put some weights. So here I'm going to tell Molotov that I want the do that scenario to be 90% of the time and the do this scenario to be 10% of the time. So this is how we actually make sure that Molotov do a realistic load testing. We ask the developers to give us a list of scenario and how often they're happening on their web service. We write them down and add those weights to make sure that when Molotov is used against a web service, it's realistic. You can also write some test fixtures. For example, if you need to set up some authentication headers when you do some testing against a web service, you can use the global setup decorator, which is basically a decorator that's going to be called before the test starts, and where you can do some, like here, for example, I'm building the auth header I'm going to use in every call. So we have a bunch of other decorators in Molotov. This is a little lifecycle chart. So before the test is launched, you can use global setup. When one worker is one coroutine is created, you can use the setup and the setup session when the session is created, and then the coroutine is going to pick a scenario every time, and when it's finished, pick another one and do it over and over again until the test is finished. And when the test is finished, you have some tear down coroutine you can use to do whatever you need to do when things are teared down. So with all those decorator, we're able to do pretty powerful load testings, and we're able to have reusable bits. For example, if we have an authentication work to do against several web services that's the same, we can write a function that's going to be used in the global setup decorator in all our services. We also have events. So for example, you can create a coroutine against the events decorator, and every time something is happening in the Molotov framework, this coroutine is going to be called. This is useful to do some printing or to do some logging. And we have events in many places throughout the life cycle of a load test. When we send a request, when a response is received, when the scenario starts, when the scenario fails, etc., etc. So again, Molotov is basically a bunch of little functions you organize using decorators. And we also have the notion of extensions. For example, if you create a Python file that contains a few Molotov decorators that are doing some stuff when an event occurs in Molotov, or when there is a teardown or a setup happening, you can group all that work in a single Python file and then use it as an extension against another file. So in this example, in my test.py, I have my rigor Molotov test. And in csv dump.py, I have the code that's required to dump all the tests I've been doing into a CSV file. And I can reuse it for other tests. I can run Molotov from Git. So basically, we have on GitHub some repository with a molotov.json file that lives on the top of the repo and has a few options that will allow Molotov to run a test by cloning the Git repo. So here, using the command line molslave against GitHub repo with the test option, is going to download the repo and call the test here, this scenario here, and reuse all the options we have in the JSON file. So we use that so it's simpler for anyone to run a test without having to do anything on their side. As long as I have Molotov installed, if I do molslave, a GitHub repo, and the name of a test, it's going to pick it up, run it, and that's it. And the last part we're doing is running it from Docker. So like for GitHub, you can run it from Docker using the Molotov image I've created. So basically, it's an image where you have Molotov installed, and when you do Docker run with the name of the repo and the name of the test, it's going to call the previous command to pull the test from GitHub and run it against your endpoint. So this two level of automation allows us to run Molotov in a continuous deployment environment just by running a Docker command. So if I summarize all the features we have in Molotov, so Molotov is simple function coroutines. It has a weight system for scenario distribution. We have hooks everywhere in the life cycle of load tests, so you can do pretty much what you want. We have events, extensions, and you can run it from Git and from Docker. So once you have all these tests, the level 2 into the heaven of load testing, when you do some load testing for services, is to plug it into your continuous system, and that's what I call continuous load testing. So we have at Mozilla some Jenkins deployment that can pick up the tests and just run it every time the service is deployed to some stage environment. So the developer push a new version, Jenkins deploy it on a stage instance, and then Molotov is called. It does a little load test, and we get back the metrics, and we look at everything and make sure that we don't have any performance regression. Well, that's it. So it's a little bit weird because I feel like I talk alone. There is no room and stuff like that. I hope you could hear me well. So if you need some more information about Molotov, you can look at the documentation here. The code is here. The logo I used is CC by Juan Pablo Bravo. That's the link. Yeah, that's it. So thanks everyone for watching this presentation.